Hey everyone, and welcome. Today we are diving deep into something that's, well, at the very heart of programming. We're going to learn how to give our code a brain. Yep, you heard that right. We're going to make our Java programs think, react, and make decisions all on their own. So let's get right into it. So, have you ever wondered, how does an app know you're old enough to use it? Or how does a game decide you've finally beaten the boss and can move to the next level? Every single time a program seems to make a choice, it's not some kind of magic. It's pure logic. And the secret sauce behind it all? Something called conditional statements. So what are they? Well, think of them as simple yes or no questions you ask your program. If the answer to the question is yes, or in coding terms, true, the program does one thing. But if the answer is no, or false, it does something completely different. Or maybe nothing at all. This is literally how you give your code the power to think. What this really all boils down to is controlling the flow of your program. See, instead of your code just running straight from top to bottom, line by line, you can create different paths, detours, and forks in the road. It's how your code can decide what to do next based on the situation. You get to be the director, telling it which lines to run and when. Okay, so let's start with the absolute foundation. The simplest and, honestly, the most important conditional of them all, the if statement. This is ground zero for adding intelligence to pretty much any application you'll ever build. Okay, so picture this. An if statement is basically a gatekeeper. It has one simple rule. If the condition you set is met, if it's true, the gate swings open and your code runs. But if that condition isn't met, the gate stays shut and the program just walks right on by, completely ignoring that chunk of code. Simple as that. Let's take a look at a real example. Imagine we have a variable for age, and it's set to 20. Our program asks the question, is age greater than or equal to 18? Well, 20 is greater than 18, so that's true. The gate opens and the code to allow voting runs. But what if the age is 17? The condition is false, the gate stays closed, and the program just moves on. Now, the if statement is awesome, but it only really handles one outcome: what to do when something is true. What if you want to give the program a specific instruction for when the condition is false? Well, that's where its best friend, else, comes into the picture. This is where things get really useful. An if-else is like coming to a fork in the road. You can't just ignore it, you have to make a choice. If the condition is true, you go down one path. But if it's false, you're forced to go down the other path. The program has to pick one. There's no skipping allowed. So let's go back to our voting example. This time, our person is 16. The program checks, is 16 greater than or equal to 18? Nope, that's false. So instead of taking the true path, the else kicks in and sends the program down the false path, leading to the sorry, you can't vote outcome. With if-else, one of these two things is guaranteed to happen. Okay, so if-else is perfect for those black and white yes or no decisions. But let's be real, life isn't always that simple, is it? What happens when you've got 3, 4, or even more possible outcomes you need to deal with? Exactly. I mean, think about a grading system at school. You don't just pass or fail. You might get an A+, an A, a B, or a C. Each of those grades depends on a totally different range of scores. We need a way to check a whole series of conditions, one after the other. And this is how we do it with an if-else-if ladder. Let's say a student gets a score of 85. The program starts at the very top and asks, is the score over 90? No, it's not. So it moves down to the next question. Is the score over 75? Yes, it is. So it assigns the grade A. And then, this is the important part, it stops. It completely ignores all the other checks below it. Once it finds a true condition, its job is done. Now, that ladder works just fine, but sometimes it can get a little long and messy. When you find yourself checking one single variable against a bunch of specific known values, like, say, days of the week or options on a menu, there's a much cleaner, more elegant tool for the job, the switch statement. And you can really see the difference here. The if-else-if ladder on the left makes the program check every single condition on its way down, but the switch statement, it's more like a teleporter. It looks at the input and just bam, jumps directly to the correct case. And in modern Java, the syntax is so clean, it's just beautiful and way easier to read. And this is where modern Java really starts to show off. A switch isn't just for doing things anymore. You can use it as an expression. And what that means is it can actually produce a value that you can save directly into a variable. Honestly, this is a total game changer for writing clean, concise code. Just think of it like a little factory. You feed a number for the day of the week into one end. The switch machine inside instantly figures out what that day is, and it spits out the correct result on the other end, either weekday or weekend. And that result gets immediately stored in our variable. It's a super efficient production line for getting the exact value you need. All right, enough theory. It's great to know how the pieces work, but let's put them all together and see what they look like in a real, functioning program. This is where it all starts to click.
The idea behind switch was actually really simple. You check a variable against a list of possible case labels. When it finds a match, it runs the code. But look closely. See that little break statement at the end of each line? As you're about to find out, that one tiny word was everything.
And that, of course, brings us to the question that has probably haunted every single Java developer at some point in their career. What on earth happens if you forget to add that break?
Well, this is what happens, and it's not pretty. Without that break statement to explicitly tell the code to stop, it just doesn't. After it finds a match, it just keeps on going, running all the code in the cases below it. This crazy, dangerous behavior is known as fall-through. And look at this. Here's what that disaster looks like in practice. If your input was 2, you don't just get 2 printed out. Oh no, you get 2 and then 3. This sneaky little bug was, without a doubt, one of the most common and frustrating things to track down in classic Java. Okay, so the good news is the people behind Java were listening. They heard the cries of frustrated developers. And starting back in Java 14, they gave the switch statement a massive, modern makeover, turning it from a source of headaches into a powerful, safe, and really concise feature.
And when I say makeover, I mean it. The difference is just night and day. On the left, you've got the old, kind of clunky syntax with the colons and the break. But on the right, that's the new, super clean arrow syntax. And it's more than just looks. That little arrow fundamentally changes everything about how switch works.
So, what's so great about this new arrow syntax? Well, first off, and this is the big one, no more fall-through bugs. That bug is just gone, wiped out by the design itself. The syntax is way cleaner, and now a switch can actually return a value, which is huge. It turns it from a simple statement into a powerful expression. And to top it all off, the compiler is now your best friend, checking to make sure you've covered all your bases. And that compiler check is an absolute game changer. A modern switch expression has to be what we call exhaustive. What that means is you have to have a case for every single possible input. If there's a possibility you missed, your code won't even compile. This feature alone just kills a whole category of bugs before they can even happen.
All right, enough theory. Let's see how this thing works in the real world.
The logic here is super straightforward. We're going to start with a student's score, use one of these new modern switch expressions to figure out their letter grade, and then just print out the result. Simple as that. Let's look at the code. The first thing you should notice is that the entire switch block is on the right side of an equal sign. That's because it's an expression now. It's actually calculating a value that we're assigning directly to the grade variable. We're also using a neat little trick here too, dividing the score by 10. That turns a whole range of scores, like anything from 80 to 89, into a single number, 8, which is just perfect for using in a switch. And check this out, another really powerful feature. You can handle multiple values on a single line. This case 10, 9 cleanly covers all scores from 90 all the way to 100 in one shot. It's so much more concise and easier to read than the old way, and you still have zero risk of that nasty fall-through bug. Okay, so now we have two really powerful tools in our toolbox for making decisions: the classic, reliable if-else, and this new souped-up switch. The big question is, how do you know when to use which one? Let's break down how to choose your best path. Here's a simple rule of thumb that'll serve you well. If you're doing range checks, is something greater than this or less than that, or you're dealing with complex logic with a bunch of ands and ors, just stick with if-else. It's what it's built for. But if you're checking a variable against a specific set of known fixed values, the modern switch is almost always going to be your best bet. It's safer, it's cleaner, and honestly, it's just much more expressive. And this final scorecard really just says it all, doesn't it? The modern switch is a total knockout. No more mandatory break statements. That fall-through bug is a thing of the past. You can return values directly. You've got these clean multi-case labels, and you have the compiler watching your back. It's just a fantastic evolution of a classic language feature.
You know, when you look at it, the story of Java's switch is really a story about progress. It shows how a programming language can actually learn from the real-world problems developers face and evolve to be safer, smarter, and just better. And it kind of leaves you with this thought, right? What if every bug isn't just a problem, but a chance for our tools to evolve?